Biodegradable plastics in 3D printing, environmental impact. Title: Biodegradable plastics in 3D printing, environmental impact. Introduction. 3D printing has revolutionized various industries with its ability to produce complex shapes and structures. However, the environmental impact of traditional plastics used in 3D printing has raised concerns. In response, researchers and manufacturers have turned to biodegradable plastics as an alternative. This article explores the environmental impact of biodegradable plastics in 3D printing and highlights their potential to mitigate the negative effects of conventional plastics. 1. Biodegradable plastics, understanding the basics, 200 words. Biodegradable plastics are a type of polymer that can break down naturally into harmless substances under specific environmental conditions. There are two broad categories of biodegradable plastics: bio-based and fossil fuel-based. 2. Conventional plastics, environmental challenges, 200 words. Traditional plastics used in 3D printing, such as ABS, acrylonitrile butadiene styrene, and PLA, polylactic acid, are not biodegradable. When disposed of improperly, these plastics can persist in the environment for hundreds of years, leading to pollution and ecosystem disruption. Furthermore, the production of these plastics often involves the extraction and processing of petroleum, contributing to greenhouse gas emissions and climate change. 3. Environmental benefits of biodegradable plastics, 300 words. The use of biodegradable plastics in 3D printing offers several environmental benefits. Firstly, these plastics have a reduced carbon footprint as they are derived from renewable sources rather than fossil fuels. Secondly, the biodegradability of these materials ensures that they can break down naturally, reducing the long-term pollution associated with conventional plastics. Moreover, the production of biodegradable plastics typically requires lower energy inputs, further reducing environmental impact compared to traditional plastics. 4. Biodegradable plastics in 3D printing, applications and advancements, 400 words. The integration of biodegradable plastics into 3D printing opens up new possibilities for sustainable manufacturing. Researchers and manufacturers are continuously exploring new materials and improving the properties of existing ones to meet the specific requirements of different industries. For example, bio-based PLA is commonly used due to its biocompatibility and ease of printing. In contrast, bio-based polyesters like polyhydroxyalkanoates, PA, are gaining attention for their biodegradability and mechanical properties. These composites find applications in automotive parts, consumer goods, and even medical implants, where biodegradability is essential for reducing the risk of complications after implantation. 5. Considerations and challenges, 200 words. While biodegradable plastics offer significant environmental advantages, there are considerations and challenges that need to be addressed. The rate and extent of biodegradation can vary depending on factors such as temperature, humidity, and the presence of specific microorganisms. Proper waste management and infrastructure are crucial to ensure the effective biodegradation of these materials. Additionally, some biodegradable plastics may require controlled composting environments or industrial facilities for complete degradation. Moreover, the performance and mechanical properties of biodegradable plastics may not always match those of traditional plastics. However, ongoing research and development are focused on improving material characteristics and expanding their range of applications. 6. Future outlook and recommendations, 265 words. The integration of biodegradable plastics in 3D printing is still in its early stages, but the future looks promising. As technology advances and more research is conducted, it is expected that the properties of biodegradable plastics will continue to improve, making them more competitive with traditional plastics. Governments and regulatory bodies should also encourage the development and adoption of standards for biodegradable plastics, ensuring consistency and transparency in the industry. Furthermore, increased collaboration among researchers, manufacturers, and policymakers will facilitate knowledge sharing and innovation. Funding should be allocated to support research projects that focus on improving the performance and biodegradation characteristics of biodegradable plastics. By working together, we can accelerate the development of sustainable 3D printing practices. Educating consumers and businesses about the benefits of using biodegradable plastics is another crucial step. Awareness campaigns can help drive demand for these materials and encourage responsible consumption and waste management practices. 7. Case studies: successful implementation of biodegradable plastics in 3D printing, 350 words. Several case studies have demonstrated the successful implementation of biodegradable plastics in 3D printing, showcasing their potential in different industries. One notable example is the use of bio-based PLA in the automotive industry. Automakers have started utilizing biodegradable plastics in the production of various components, such as interior trim par, TS and air intake manifold prototypes. These biodegradable parts offer equivalent performance to traditional plastics while reducing their environmental impact. In the consumer goods sector, biodegradable plastics have found applications in the production of packaging materials. Companies have started using bio-based biodegradable plastics for food packaging, ensuring the safety of the product and reducing waste pollution. These packaging materials can be easily composted, reducing the amount of plastic waste that ends up in landfills or oceans. The medical field has also benefited from the integration of biodegradable plastics in 3D printing. Biodegradable polymers like bio-based polyesters are being used to create personalized medical implants. These implants gradually degrade over time, eliminating the need for additional surgical procedures for implant removal. This not only reduces complications for patients but also minimizes the overall medical waste generated. Furthermore, the construction industry has begun exploring the use of biodegradable plastics in 3D printing. These case studies demonstrate the versatility and potential of biodegradable plastics in various industries. The successful implementation of these materials in 3D printing showcases their ability to provide environmentally friendly alternatives to conventional plastics. 8. The role of regulation and certification in promoting biodegradable plastics, 300 words. Regulation and certification play a crucial role in promoting the use of biodegradable plastics in 3D printing. Establishing clear standards and guidelines ensures the quality and reliability of materials, while also fostering consumer trust and market acceptance. These certifications provide manufacturers and consumers with confidence that the biodegradable plastics they are using meet specific performance and environmental requirements. In addition to certifications, governments can implement regulations that incentivize the use of biodegradable plastics and discourage the use of conventional plastics. This can be done through taxes or levies on non-biodegradable plastics, promoting the adoption of more sustainable alternatives. Government procurement policies can also have a significant impact on fostering the adoption of biodegradable plastics in 3D printing. By incorporating environmental criteria into their procurement guidelines, governments can support the demand for these materials and facilitate their widespread use in public projects. Education and public awareness initiatives are equally important in driving the adoption of biodegradable plastics. 10. The economic factors of biodegradable plastics in 3D printing, 300 words. In addition to the environmental benefits, biodegradable plastics in 3D printing also present economic advantages. Although they may be initially more expensive than traditional plastics, the long-term cost savings and market opportunities make them a viable choice for manufacturers.